Okay, first you have to set up the environment. So at the very beginning you need to download the Docker. So go to the Docker website and you can download for your Mac or Windows, whatever in your operating system. So after running the Docker, so you need to install the Java and Java 21. You can go to the website and you can download Java 21, install, so you can search it. So you can go to, for Windows, if you go to Windows you can download Windows. So you can go here and you can download the Java 21 because I'm using the Java 21 version. And you need to also install the Maven. So for Maven you can install the Maven. Install Maven. If you search in Google, it will show you the required documentation. So for your environment you can choose whatever you want. You can install Maven. So after all of this installation you can check the environment. So let me show you my environment, Java version. So here you can see I'm using Java 21 0.0.1 and my Maven also is running Maven version. So I'm using this Maven version. These three requirements only: the Docker and Java 21 and Maven. So now let me go to the project setup. So after I will show you the Git repo. I will add the Git repository in the description. You can download the full project from here and just clone the project and open it. Then you will see something like this. So let me set up first the gateway service. So for the gateway, so we have created the gateway independent Spring Boot project. So it will include only the gateway, and also it has the fallback controller. So I will show you later. Let me show you first the module where we included all these six modules in one file in one project, which is Finpay. You need this pom.xml file. So inside pom.xml, so we can the Java version and also Spring Boot version. So it's if we add all of this module here, so we can handle all of these microservices from one location. So something like this. So if you do not need to build all of these microservices one by one, so you can just run this Maven install Maven clean install. So it will build all of the service in one command. So you are seeing the all service is success. So for now let me show you the API gateway service. So let's me go to API gateway. So for API gateway you need some dependency. So this is the starter actuator, starter gateway, and we are using Spring Cloud starter with circuit breaker, resilience 4J. Also we need the Redis dependency, and for Webflux UI, for Webflux OpenAPI, you see the Swagger UI docs. So for Swagger UI we need these things for setup. So this is our pom.xml. So we need this repackaging. When we run the clean install, we need to recreate the jar where it is inside the target folder. So for this one we need this one to goal. And let me show you the application.yml. So inside YML, so we are running 808 port for gateway service, and also we have the Redis setup. So Redis is running localhost 6379. So it is the right time to show you the Docker. So let me show you the Docker first, because I forgot. Okay, and this is our Docker setup. So we have lot of services. So we have the PostgreSQL, whereas I keep the same password. It's very weak and don't recommend to production. It is for testing. So, and also we have pgadmin to see the database. So there is some environment variable, so you can just copy and paste, and it's exporting 5050 port. And we have Redis server. Here is the port we are running for Redis, and we need Zookeeper environment for to running Kafka. So we have Zookeeper setup here, and here is the Kafka container. So we have the Vietnamese Kafka 3.7 and the environment variable we need, and also we need the Prometheus for Kafka. So this is the Prometheus setup, and also there is the Zipkin for tracing, and here is the Grafana to view the system performance and other things. Also the Kafka JMX exporter to export the data to Grafana. We need this from Kafka to Grafana. We need this exporter, which is running on 7071 port. And here is the Elasticsearch, which will transfer to data to Kibana to see the logs through Logstash. So here is the all setup. We have the volume Postgres and Elasticsearch data. So let me run this Docker composer. I already run this a lot of times, so all of the dependency is downloaded, so it will not take time. So for you maybe it will take some time. So let me run the Docker compose file. Okay, so you see it's running instantly. So now I will show you the Docker PS. Let's see, it's running all. Okay, so it's running everything good. Okay, so now I will run the every service one by one, because I am running this 6 service in my local machine, but I am other dependencies are in Docker. So first let's clean all of these microservices and create the jar file. So you can run maven clean install. I already run this. Let me run one more time. So it will compile and it will create the jar file. So I can run the jar file too, or I can run from here with maven spring boot run. Some jar file is you can go java jar, you can go to target, and what is this service API gateway. Here you can run like this. So it will run jar file too. So let me close this one because I want to run with maven. So let me run this one. So it's running 8080 port. Okay, so for 8080 port we are connecting all service. So let me show you the gateway config. So here is the gateway config. So you see we are using the Redis limiter and the key resolver. Key resolver is the key to identify the request uniquely. It cannot identify the token, so we need the key resolver class too. So you can go to the key resolver from here. So we have the string key resolver interface, and also we have the Redis rate limiter. Okay, let me go to Here we have the rate limiter from Spring framework. So we have to inject this in constructor to initialize, otherwise it will throw error. So route, we are using the route locator. You can configure this API gateway through YML, and also you can configure to Java class, which I prefer to do. So here is the auth service. So this is the auth service we are configured in the YML. So let me show you the auth service YML. So where is the auth service? So this is the auth service. Go to resource. You can see we have the Spring Boot application auth service. So I will show you the next details later. Let me complete the API gateway first. So this is the API gateway YML, and this is the Redis configuration, and this is the Swagger documentation for to see the UI in Swagger, which I show you earlier. So this is the default URI, and here is the gateway API documentation, and we name it API gateway docs. We name it as we want, but this is the common path. So v3 API docs, and this is the name of gateway from the here config. So you can see, let me show you side by side. So let me split. Oh, I have to split. Oh, there is no split. Okay, so here you can see the auth services. This is the URL for auth services, which where we can identify. If we find this auth services, then it will redirect to this auth service URL. Our auth service is running 8081 port. I will run it later. So, and our account service will run it 8082 port, and it will identify with the prefix accounts. And every other service also running. Transaction service will have the prefix transaction, and it has the circuit breaker. So if transaction service somehow is not accessible, so it will forward the fallback controller. So we have the fallback controller here. So here is the controller in API gateway. So it will come here, and it will go to this method, and it will return this message. So you can customize it whatever you want. And this is our notification service. It is running on 8084 port, and here is the fraud service, where we are including the rate limiter. So this is the rate limiter, Redis rate limiter, and user key resolver class interface, which is running in 8085 port. I showed you earlier that if there is something that with bus capacity more than 10, then it will throw error. Okay, and here is API gateway documentations, which is defined here. So you see v3 API docs gateway. Let me close this one, and you see v3 API docs gateway. So I need to implement filter here, because our API Swagger API is running to this endpoint. So when we find this path, it will replace this path with this path, and it will direct to the our desired documentation service. So it will see the gateway service. So, and also the auth docs will redirect to the 8081 port, and rest of the things are mostly similar, just name is the different. So you see, same. So this is our API gateway service, nothing more, only these 2 or 3 classes, and you can run it from here. I already ran it, API gateway. So from here you can check the Soga UI. So if you go to the localhost, I have already this one. So you see the fallback transaction. So this is our one API which I showed you earlier, and also there are other, but you cannot access this one because we are not running. If you go to the, suppose you go to the auth docs, you will see some error because we are not running running the services. So let me run the auth service. Okay, so you see we have one error. So let me run the auth service, spring with run. Okay, fine. So let me, so it's an auth doc. So you see now we have the authentication service running. So let me go to the auth docs. Okay, you see the all the API we can see from here. Now let me explain the authentication service, how we can run this. So go to the auth service. So it is a little bit complex because here is we have JWT token. So you can go to the, first you need to go to the pom.xml, and here you can see the all the dependencies for Spring Security, Starter Security, and for auth to server, resource server, and we are using other dependencies, and we have also the other dependencies like Lombok, Web, MVC for Spring Doc, and Sogar for Sogar, which I showed you earlier. So that's all the dependencies. We need also repackaging when we need to create the jar file. Okay, so this one I did not tell you yet. So we have one common service where we are including DTOS utils and etc. So this is our dependency we have created by our own. So here is the common service. Let me explain you right now because it comes in the dependency. So for the common service, we have the pom.xml to run run all of this function. Here is the some dependency. We need also Spring Security because we have the key validation here to verify the JWT. We make it common in the common module because this validation will use all of the service to validate the JWT token. So here is the Spring dependencies. So this service we do not need to run we do not need to export in any port. That's why there is no there is no YML. We just need to build it, and we will use this jar file in the dependency. So that's why we are using. So here is the some DTO. We have the accounts DTO. I have included all the DTO here, so we can reuse it from in other services wherever we want. We just need to include this dependent. Where is it? So this here, we just need to include this dependency in any other service, and we can use all of this service. So you can see all of the other services DTO is here, and we are using some enums, and also we have some logging utility function, and this is the utility function for load the private key, and for using for decoding and read the public key from the YML. we defined in the OML the public key location. So we will use this service, we will use this utility function in other service. You will see in action later. So this is our common service. So this is the common module. So that's all in auth service pom.xml file. So let me go to the others, explore the other file. So here is the resource application.oml for auth service. So we need the database connection and security. So this is the private key and public key which I am talking about. So how to generate this private key and how to generate this public key, so I will show you now. And the location of this private and public keys here. So you need the keys, the resource keys. So you have two keys. So if you go to the readme.md, you have the details instruction here. I think I have write down the public key generation command. Where is it? Here. So you need to open cmd and you go to this location to save on this location. You just use OpenSSL to generate the private key, and to for verification you use that private key to generate the public key. So use this command and save these two key. It will be saved here. So this is the generation for public key and private key. Later we will use the public key from other services to verify this JW2 token. Okay, so this is our resource folder, and let's go to the Spring securities first. So we have the Spring security. So we need to expose some service in sub MPI because we do not need authentication for this, for the user creation and also the login. And also we need to expose the actuator to access the Prometheus and others Prometheus APIs. And also we need to permit all for the Sogar API documentation. So those do not need to authenticate, because we will authenticate the others API in each services. So as simple as that and nothing else. So you can go through this. So so we have authentication manager and some other bin to verify the keys, and also the password encoder. So you can go through this class. And we have the open API config to this is the authentication for open API, I mean the Sogar API. If you see the authentication feature, so if you do not add this, so you will not see this authentication, you cannot call the services. So let's go to the source code. So you add the configuration here. So I'm not explaining everything in details, because if you see the codes you will understand everything. And also it's written in readme file too. It will be more lengthy if I explain more details. So we do not have to memorize everything. So just sometimes we need to search in Google and you will find the explanation too. And so here, so it is very challenging to connect with all of this architecture which I show you earlier. So this is the main thing I wanted to show you. So to connect all of this service and to view the visualized data, so it will be a good start with all tech stack. So next I have created the repositories and models. So here we have the user entity model, role model. We have two role, user we have two role, user and admin. And here is the location model where we are saving some location data. So this is for only for testing purpose. So there is no any mandatory to use the location, only use the role and user entity. So we have the user entity here, as simple as that. So we are connecting location ID and role ID to here. Okay, so we are using user details implements for user details. We have the exception, global exception handler. So if there is any error, so we are using the REST controller advice, so it will get all of the exception in a good format. So we don't need the database. Yeah, we have the rule seeder, because at the very beginning we do not have rule. So I have created one seeder to input the user rule and the admin rule. So, and here is the course. So course config in auth service. So from API gateway we need to connect the auth service, so we need to allow the API gateway service from auth service. So this is our API gateway URL. So it is running in 8080 port. So we have to set up this cross auth service, otherwise we cannot connect, it will be an error. So finally the user controller and auth controller. So in auth controller we have the login function and we have the create token function and create scope. So these are the authentication auth controller constructor to inject the JWT encoder and authentication manager. And from the login you have the login request. In the login request you have the username and password. So you have the authentication manager to authenticate, and after authentication you have it will create the JWT token, where we are including the user ID, email, and also the rule. So scope is the rule, so admin or user. So this is the name, authentication dot get name. This is the subject. We need to include the name in the subject, and it will be valid 3600 seconds from now. So that's all the controller configuration. Okay, so now we can use this authentication service right now. So let me go through it. So let me go to the authentication service controller. So you can see, let me check the Postgres. I am already running in from Docker. So you can go to the 5050 port. So we are already set up in the Docker for 5050 port for PostgreSQL. And you can see I already have those table, because previously I run this application to demonstrate all of this feature. So let me go to the users. So select. So we have already one user. I want to create one more user to show you. So let me go to the user creation. Just I did not add any validation, because it will take too much time for adding everything in details. So let me show you the mandatory field which I have to fill up. So just put it the gmail.com, and username password will be string, role should be okay. We can use the user or admin, it's mandatory. So location, okay, let me keep it some Japan. Okay, Japan. Oh, it's also not mandatory. I mean, you can put any string. Okay, so we do not need this one for authentication, because we already whitelisted this one. So let me execute this one. You will see some response. Okay, user ID 2, we have this. So username is string and also we include the password is also string, and the role is admin. So now we will log in with this. So let me go to the login controller, login docs. So first let's try. So we have the same string so make it more easy. So we have the token, you see we got the token. We can call it from postman too. So as we already implement this feature, so it's that's why I'm using from here, so it's good to see from here. Now we need to go to the account docs because sorry, I did not run the account, so you see the error. So let me run the accounts. Where is our accounts? To create the account, so let me go account service. So you just from the root project you go to the account service and just run maven mbn spring boot run. Okay, the account service is running. Okay, let me reload it. So you see we are accessing everything through API gateway. We are not calling the port 8082. You see the account service is running on 8082 port. You see from here started where it is here, port 8082. We are running from API gateway. You see in the API gateway here, you see the API gateway route config. So API gateway here account service, we are pointing to the 8082 port. If any API start with prefix with accounts, it will call this API. So this is the benefit of API gateway. We can use one URL. Here we can use the Eureka also LB. So I did not use it right now. I will use it later. So let me reload it right now. So we have the account docs. So here are some APIs. I did not add too many APIs, so that's why I need to check from the from the database. So let me go to the accounts database. Okay, so we have already 2 account here, so let me create one more account. So I have the authorization key. Yes, okay, let me authorize it. And if I try account, so only the minimum information, so account email, let me make it string@gmail.com. Is there any? No, it's test. Okay, let me make it string gmail.com. so make it initial balance is 300. Let's execute it. Okay, we have created. Let me check. Okay, we have this. Now we want to transfer some money from this account to this account. So let me, I already copied this ID, account ID. So let me go to the transaction documentation. Okay, so now it's time to run the transaction service. So let's run the transaction service. Just run spring boot run. So it will run. Okay, so it is running 8083 port. Let me reload it. Okay, we got the transaction. So here is the IDM potency key. So if this key is same, so it will get the same transaction and it will process the same transaction, and if it's fail, and we input the same transaction, it will retry the same transaction again, so it will not be duplicate. So let me make it test 10. So let me change the account ID. We want to transfer from newly created account to this account. There is 290. Let me transfer 10. So when we transfer, so it will fire an event to Kafka, and also it will send notification, and also it will check the fraud service. That's why we need to run all of this service. So it's time to run other service too. So I will explain the other service. First let's run the service. So go to the notification service folder and just run Maven Spring Boot run, and it will spring up. And let's run the fraud service too. Go to the fraud service folder and run this command Maven Spring Boot run. Okay, so now everything is running. Now we can transfer. So let me execute this command. Did you authorize? No, we need to authorize this. So if we send something like this, so you will see 401 unauthorized response status. So let me go to the authentication docs and get the token. So here, try it, execute. Okay, get the token. So it is protected by JWT Auth2. So transaction service, and here we have already everything. Just authenticate this, authorize. Now we need to please try. Okay, so everything is safe. Let's execute. Let's transfer train. Okay, I think it will work. It's loading. So okay, the response is completed. It's transferred $10. Okay, now let's check the accounts. So if we refresh this one, you will see the $10 will transfer from this account to this account. So action. Okay, it's good, it's working. And you can see the notification too. So I already set up the mail trap for notification service because there is a successful transaction. We can see the notification. So you can see here a few seconds ago. So we have the transaction completed successfully. So I want to show you the fraud service too. So you can see the fraud check database. So you see the fraud check this transaction ID, which one? This one. Transaction, where is the transaction service? Here is the transaction, all rows. We just transferred 10, so transaction ID will be this one. So this one is started A685. Okay, A685, and here is A685, that means this one. So this transaction, so this is not a transaction, is valid. So I will show you some invalid transaction, so it can detect as fraud. So let me continue. So where is my transaction? Okay, let me show you the Kafka event to because it's already fired the Kafka event. So here from transaction service you can see the Kafka in action here. Kafka, so it's sending the transaction. So from where it's sending? It's sending from transaction service. Let me go to the transaction service. So here is the transaction service. transaction service, where is the service? Here. So here is the transaction producer. I will show you the setup later. So from here it is sending the transaction event to Kafka, and the fraud service, here is the fraud service will consuming this Kafka. So you see the received transaction from Kafka ID is 859A6, and this is the account number. So amount is 10 and user is this user. So Kafka is also working. So where we were in the transaction service. So this is the so all are in action right now. So now it's time to show you the logs, the Prometheus and the Grafana, because in transaction service, let me show you the pom.xml. So we are using the Kafka here, and we are using the Prometheus, and we are using the Logstash. For this is for Elasticsearch and Kibana to transfer the logs from Elasticsearch to Kibana. So I'll show you later. Let me show you the Prometheus first and Grafana. So we are already running the Grafana and Prometheus in Docker. So I showed you earlier. So we have the required dependency here. So I will show you the Zipkin too after this. So Zipkin will trace the logs. So okay, so this is all the dependency. Okay, I forgot one more thing. So how transaction serving is connecting with account service and other services. So this is the third party dependency OpenFing. So we have to configure this one. So let me show you the config. So this is our client. So we have three clients which will connect. Transaction service will connect account service, fraud service, and notification service. Let me show you one. So account service, here is the Fing client and annotation. So this is the service name, this is the service URL which is running on 8082 port, account service, and we are connecting to this API, debit credit. When we transfer money, we need this function, and to get the account we are creating one more API. So it will call the debit and credit API to the account service which already built in account service. So let me go to the account service. So you see the controller here, you have the debit API and credit API, also the transaction ID, I mean the account ID.
It's 2 o'clock.
Okay. So so this is the course config too, because we are connecting, we are requesting API for account service from transaction service. This is our transaction service URL, so we need to whitelist this one too to connect, and also the API gateway for the Sogar documentation. And here is the transaction model and repository. This is as usual. You can check it, it is very easy. And also the security config same as before, because we are exposing this endpoint to access the actuator data, which is Prometheus. The security config, there is nothing, and this one is same also, because we need to make it authorization for this one for all the services. So we have added this one for all the services. Just change the service name, so it will work as expected. And for public key. So this is the public key. We have to use it here. We will store here, and in the application.yml for other services rather than account service rather than auth services, we need only the public key. So you specify the public key here with Spring Security application.yml and also the database connection. So it will get the public key from here. That's all for the account service. And so let's go back to the transaction service. Or is the transaction service? Okay, so that's what we are talking about, how to connect with account service. So similarly with fraud service, we are connecting through API, Ping client API. So for the notification service, same. So now go to the okay, we are running all the services. So before going to the Prometheus, so let me show you other services too. So for the fraud service, what is the fraud logic? So let me show you the fraud logic. So here is the controller, fraud controller, check fraud check. So if we go to the, so if the amount is more than 10,000, so we are counting as it's fraud. So it will be fraud transaction. So I will show you later. So this is the business logics. This is not the actual business logics. For the testing purpose, I just use this. You can change this whatever you want. And okay, now for the Grafana and Prometheus, so we have integrated it in the transaction service. So you can integrate with other service too. So for this one, you need to add these dependencies. So let me go to the Prometheus. So in the Docker, we see that Prometheus is running on, where it is, Prometheus, it's running on 9090 port. So and we have the configuration for Prometheus. So we are exposing two services, our transaction service and the fraud service, and also it's the Kafka JMX exporter. So the Kafka events in data will transfer with this exporter to Grafana. So now let's go to the URL for Prometheus. So localhost colon 9090. So here is the Prometheus. You see, if you go to the, we can implement the alert here too. I did not implement it right now, so maybe later. So target health, if you see our target health, our exposing for those services. So if you go through this matrix, for suppose if you go to this one, so let me copy this, and sorry, not copy okay. Okay, so this is the Docker host, it will not work here, so we need to change it localhost. Okay, here is the matrix, it's exporting everything similar as the fraud service too. If you change the port number, it will change. Okay, and now this health is okay, running is up. If you stop some services, so it will be stop, so it will be show you that it's down. So now go to the Grafana, because we are already installed the Grafana in port 3000. Okay, so here is the Grafana. dashboard. So for the Grafana, you go to the data source and you already installed in Prometheus. So for the, let me show you, this one is the default. So you put the URL for Prometheus URL, which is this one, to get the data, and you select the, okay, that's all I think, and everything as default will work. Then save and test. So successfully we read the Prometheus API. Now we have the dashboard. So let me delete those dashboard to make it from start. Okay, so now we want to see the system performance for two services. So let me import the dashboard. So you go to the grafana.com grafana dashboard, you will see a lot of dashboard. So this is the one dashboard. So this is pre-built. So if you build it by yourself, it will take long time. So you just copy the template and click the load, and and select the data source you already set up, the Prometheus. So import it. So you'll see the logs here, system logs. So here you see the two service we have implemented for this one, the transaction service and the fraud service. So this one too. For the, we will add one more dashboard for the to see the Kafka. So let's import. So I have added some custom query to load the dashboard. You will see this file in the docs folder in the repository. So let's import this and use the Prometheus. So you see some messages in the UI. So there is some few messages, so that's why not too much. So that's how you can set up the and see the Prometheus and Grafana in action. Now I will show you the Zipkin for tracing services, for tracing logs. Sorry, we have implemented Zipkin in two services, in fraud service and transaction service. So let me show you the pom.xml. Here we have implemented the Zipkin. You already saw this, I think. So where is it? Micrometer. Here, Zipkin. So you need this two: micrometer, tracing, and Zipkin reporter. For this one, is there any config? Yes, we need some config, tracing config. You just implement this simple tracing from micrometer tracer. Okay, that's all I think. And also you need to configure the YML too. So go to the YML. So here you see the Zipkin. Here, tracing management, you put the management and tracing, sampling, probability 100%. You see all of that, all of these things. And here is the Zipkin URL, and it will scrape through this. Okay, this is the setup for Zipkin. So let's go to the Zipkin now. It is running which port? It is running 9411. So localhost 9411. So here is the Zipkin. So if you click plus icon, you can see the service name and other functions too. Let me show you the service name. Here is the two service I already integrated. So transaction service, if you run the query, you see the transaction tracing logs. So you can see details, everything. And if you click another one. So fraud service, you will see the fraud transaction here, you see. So this is the Zipkin tracing. So for I forgot to show you one more thing for Kafka. So because for the Kafka we need something, sorry, this is for Elasticsearch. For Kafka we need Kafka producer config. So you can check these files to in transaction service to produce Kafka message, to produce Kafka event. So here is the producer configuration, that's all. And other class is as simple, which service you want to connect, you need to add in course config for whitelisting. And also this is the Fin client, as I told you before. So this is the Fin config for authentication. So when you send request to other services, so Fin client will not have default authorization, because that's why we need to create one bin. So to inject the authorization bearer token in header. So in every request, when it will connect, it will send in another request, it will send this authorization token, so it will authorize accurately. So that's the Fin client setting. And what others? So transaction controller, you already saw it. Transfer, so this is the transfer function, we already saw it in the transaction service. So this is the transaction controller. So we are using account client, notification client, fraud client to connect all of these, and also using transaction producer for Kafka. So we need to initialize this repository. And for the transfer, first we are checking the idempotency key. So it's transactional. So if anything happens unusual, so it will roll back. And also if there is already there is a transaction with the same key, so it will get the same that key, so it will not, there is no duplication. So if it's pending or completed, so it will return the same response. Otherwise, if it fails, so it will try again for retry the same transaction. So that's how it's implemented, idempotency key, so it will not be duplicated. And after that, it will also send an event to Kafka, and fraud service will consume this event. And then it will also connect with account service for debit and credit. And there will be also it is connected with the notification service too, so it will send the email notification through email channel. So if any exception occurs, so it will send an email for transaction failed. So that's all the transaction service, as simple as that. So right now only the remaining things is the Elasticsearch and Kibana. So for the Elasticsearch, we need to define the exporter from Elasticsearch to oh, I forgot the Kafka JMX config. So this is the Kafka JMX config to send the data to Grafana. So here is the port number for Kafka port, and then just check this in the Docker Compose file. So in the Docker Compose file, you see 999 in Kafka. So where is it? Here, the JMX port is Kafka. So you need to configure this port and make some rules for exporting the logs. And this is the this is the Elasticsearch logs to transfer the logs from Elasticsearch to Kibana. So this is the configuration for Logstash. So you will see the pom.xml. You will see there is Logstash dependency here, Logstash logback encoder. You need this dependency, and you see in the docker compose.oml file, you have in the, where is it, Elasticsearch. Yes, in the Elasticsearch you will see it is running on 9200 port, and Logstash is running on 5001 in our local host. It is exporting 5001, and inside the docker it is running in 5000 port. So you have to put the 5000 here because it's inside the docker, and this is the container name Elasticsearch, which is running 9200 port, and we are creating the index, our transaction service, with the date. So that's the configuration for Elasticsearch and Kibana. So let me see, is there anything else? Okay, the Kibana, yes, the Kibana is running on 5601 port, and it is connecting with Elasticsearch 9200 port, and Logstash is transferring the log. Now let's see it in action. So let me go to the 5601 port, localhost 5601. Okay, the Kibana is running. Now you go to the index management, where you will find it stack management, and go to the index management, and you see the transaction service logs. So yesterday I used this service, so yeah, there is a one more log yesterday. So this is the today's log, and you will see this you can see this from here in the discover. So go to the discover and select the transaction service logs, and you see it in action here. So you see the transaction service logs here. So that's how you can see all the logs for transaction service. You can implement this to other service too. For the time consuming, for the time, I just implemented for one service. So let me show you the rate limiter. So let me go to the API gateway route. Okay, so we have implemented the rate limiter in Fort service. Now I will fire some API more than 10 times. So let me copy. I need the authorization key. Let me get the authorization key, which is from auth docs. Try login, execute. So this is the authentication key. Let me update it from here. Okay, updated. Now we are calling. Okay, we are calling this frauds service, and to this transaction, let me get the right transaction. So this is the fraud check service. Let me get this transaction. To get this transaction, so where it is. Okay, Okay, so if we run this query, so it will run simultaneously from 1 to 20 times. So you will see after the in the 11th request you will get the too many requests. So let me run this here. So I already ran before, so let me run one more time. Okay, so you see 4 to 9 too many requests. From the 10 up to 10th request, you see the transaction ID. We will get the response, success response for transaction ID. After that we are getting too many requests. You see the success. Okay, but sometimes we are getting too many requests because we are limiting rate and bus capacity is 10, but I am running here in 1 second in loop 20, 1 to 20. So you see in action. So now let me show you the fallback response. So if you will see this response. Right now our transaction service is running, so if you send the request you will unauthorized. Let me get the token. So okay, I got the token. I already set up this token in a script, so it is automatically injected here. So let me go to here to transaction service, so you get the information. So for if I stop this transaction service, you will see some fallback response. So let me stop. Where is my transaction service? This is the transaction. Let me stop this. So it stopped. So now if you hit, okay, the transaction service is currently unavailable, please try again later. So that's it. And I forgot to show you the fraud check. So right now you see fraud check database, fraud checks. So there is no fraud, right? So let me generate one fraudulent transaction. So our logic is, if the transaction is more than 10,000, so it will be fraud. So let me get the token again because I already make it. So okay, go to the transaction docs. Okay, we stopped the transaction service. Let me run it again. Let's run it. Okay, it's running, I think. Okay, now make it authorization, authorize, close transaction. Let's try it. So before I used the same key, it will not accept. So let me show you that one too. So before I use test 10, right? So let me make it test 10. So let me update the account ID too. So we want to transfer from account. Which account? Let me go to the account database. We want to transfer from, let me transfer from this account to this account. Okay, so where is here? Okay, let me transfer 30. It will not transfer, it will, you will see the same thing. You see, you transfer 30, but you are getting the 10 completed because it's the idempotency key protected is the same key, so there will no possibility to do for duplication. So now let's make it, we have 10, 30, let's make it 40. So we will transfer 30. Now let's make it 35. Okay, now execute. Okay, you see 35 completed. Now if you see database, so let's make it. So you see it's transferred 35, and also you see you will see the notification to here, notification transaction successful completed, and all, and everything you will see in action as usual, as like before. So right now I want to show you the fraud. So let me show you the fraud. So it's valid request, so let me transfer more than 1000. Okay, so let's make it 20,000. Make it 20,000. 20,000. Okay, let's execute it. It's running. It's failed. So why it's failed? Because it's fraud, it's detected as fraud. So let me show you in database. So it's, you see the transaction failed, so everything is firing event. And here is the database. If I refresh the fraud checks, you see true, amount exceed threshold. So which transaction? It's this transaction, 34 and starting with 11E. So here 34 starting with 11E. Okay, so you see 20,000 failed. So that's all in actions. This one is my first tutorial, so there is some mistake, I think. So if you find anything complicated, or if you do not if you face any problem to run, you can comment and I will help you, no problem. So maybe if I miss anything to explain, so you just comment it, and I will show you how you can run it, and you can use all of this feature. So that's all. Thank you very much.